remember. Hand this back. Questions? Then let's pick up where we left off.
Hazel, Giselle, and Tristan. Let's see. Got 1 of those. 0.5 of those. 2 of those. 2.5 of those.
All right. So what I want to know is what is the current flowing across each resistor and what is the potential drop across each resistor. So voltage and current. Little subscript I just indicates some generic value. What's the first step? What is a first step?
You could start place with the parallels.
Okay, so come up with an equivalent resistance.
Yeah.
All right. Which ones are we going to combine first?
1.5 ohms and 2 ohms.
All right. So they're in parallel, resistors in parallel. How do you combine them?
Do the reciprocal?
Yep. So that's 3/4, no, that's 3 halves. So I have 2/3 plus 1/2 is equal 1 over the equivalent. And that is faded there. Doing the fancy math, well, that's 0.5 and 0.6 repeating, so that would be 1.16 repeating. Now, in this particular problem, I have run into situations where if we round it with too few significant figures, we end up with some discrepancy in the end. And the first time I ran across that, I thought, all right, was there a careless error we made somewhere? But it really was just a rounding thing. So we do need to be careful. And actually, I'm going to express this as the fraction. Oh, that's 1 over the equivalent. So common denominator would be 6, so that is 4 plus 3, so 7/6. That matches with that. So my equivalent resistance here is 6/7. Now what?
Then we do the series.
Which ones?
The 1 and the 6/7, so just add out.
Okay.
So just 1 plus.
Oh, wait, nope, not that. Why is 1 not in series with the 6/7?
Oh, it's the gap, the line in the middle.
The junction. Yeah, there's a junction in between. Series will not have a junction.
So do you do the 2.5 ohms, 3.5 ohms?
That are not, are you thinking series or parallel?
The parallel.
Not in parallel because there's another resistor.
Is it in series with a 3 ohm?
Yes, it is. We have this combination here. That is in series. So if we combine those, how do we combine them? All right. So 27 sevenths. Oops. So we are now down to, I got the battery here. I got my 1 junction going this path. I've got 27 sevenths. This way, I've got 2.5. This way, I've got 4. This way, I got 3.5.
Would the 2.5 and 3.5 be in parallel?
No, because the 4 is in between.
Oh,
So is the 3.5 and 4 parallel or series?
No, neither, because the 2.5 would be in between. We're sort of at an impasse here. Trying to think how I had it configured before so that we wouldn't run into this. Oh, that 1 wasn't there the last time I did this. That's one of the issues. So I can talk you through how to solve this one, or I can get rid of the 1. We can continue on the path that Jack laid out.
You can do this one.
This one? All right. So when you're in this situation where you can no longer reduce it, you come to a system of equations. So I know that there's some current flowing out of the power supply. Whatever current's flowing out of it is going to go across that 1 ohm resistor. And for that absolutely stunning, incredible visual effect. So whatever current is flowing along this path is going to be the same. So let's give it a label. I'm going to cleverly call it I sub P for power supply. I know it is going to split at wherever there is a junction. So it's going to split here. And going across this path, we have a current, which I'm just going to call I sub 1. And going down this path, I'm going to call it I sub 2. Now I sub 1 is cruising along here and hits this junction at this point. I sub 2 cruises along and hits this junction. Now I know that the current is generally going to be flowing in a clockwise direction, just because of the way the battery is situated. So I2 is going to split, and I'm going to have some of it go this way, and I'm going to cleverly call this I3. And then going down here, sure, I4. Just the creative juices are just flowing. Now I have I1 and I3 combining at this point, and they're going to produce some current flowing down this last path, I5.
Whoa, that's a lot of eyes.
Yeah. Therefore, how many unknowns do we have?
5.
How many equations do we need?
5.
Yes. 5 equations, 5 unknowns. I will say, typically I don't do the 5 equations, 5 unknowns with 152 or 252, but you can handle it.
Appreciate it, Jack.
Yeah, I believe in you. So what we're gonna do is we need to come up with our 5 equations. All right. Well, I know every junction has an equation. Now, they're not all independent of each other, but we'll just do it until we run out of independent ones. So at this junction right here, what is the current flowing in?
1. Sorry.
Which of the currents is flowing in?
Current sub P.
All right, so I sub P flows in, what's flowing out?
I sub 1 and I sub 2.
So our first equation. Live. I sub P equals I sub 1 plus I sub 2. All right, one equation down. All right, let's cruise on to the next junction. What equation comes out of this junction right here?
So would it be I sub 2 equals I sub 4 plus I sub 3?
2 equations, done. All right, give me another equation.
I sub 5 equals I sub 1 plus I sub 3.
I sub 5 equals I sub 1 plus what?
I sub 3.
3 equations, done. So simple this is. Well, actually, this part is the simple part. It's the solving that where most of the Carol's errors happen. All right, we can do another equation here. It's not necessarily independent, but we have 4 junctions. So potentially we have 4 equations. Now, I'm very confident that the last equation we can derive from these, but what is that last equation?
The one that we derived from those?
No, well, the one that I suspect we will be able to, but the one for this junction right here,
I sub 4 plus I sub 5.
Equals I sub B.
all right. Now, I know that I sub 2, just combining these 2 equations here, I sub 2 equals this, so I know that I'm going to shorten my handwriting here by just writing the subscript. We're all dealing with currents. When it comes to actually solving it, I'm going to erase what I'm about to write, but I don't feel like writing all the I's. So P equals 1 plus 4 plus 3. These are just the subscripts again. These are not the actual numbers. And I know 1 plus 3 is 5. Within context, it's a legitimate statement. Here's my 1 plus 3, so that's 5 plus 4, which is what we have right there. So this 4th equation is not independent. If we try to actually solve the system of equations with this in it, let's say you're using your calculator to solve it, you will end up with an error. Years ago, I was doing this, something similar to this with a high school class, and they just hadn't learned how to use their calculators to solve system of equations. And so I was just about to point out that they were not independent, and they said, no, we can do this, we can do this. We just learned how to do it in math. So they all pulled out their calculators and they all got it, and then there was those puzzled looks because they kept getting errors. All right, so we need to somehow deal with this. Any questions on this before I erase part of it?
You can do system of equations in the calculator.
Yes, you can do a system of equations on a calculator. The upside is, if you type it in correctly, it is incredibly fast. The downside is, if you mistype something, I won't know it, because all I'll see is your system of equations and then your answer, and there's basically
You're gonna jump
no
through
partial credit in
marks.
between there.
Fair. Okay then.
And if your system of equations is set up right, you can always just do a quick check of, oh, here are my answers, let me plug it back in, make sure that it works for at least a couple of the equations. All right, Obviously, we started out with, there are 5 unknowns, we need 5 equations, and yet we have only 3. The other 2 equations come from the voltage rules. I need 2 loops here. I need 2 equations, so I need 2 voltage loops. And it doesn't matter which ones we do. We have a choice of our choice of loops. This is the basic setup right here. I have this loop right here. I have this loop right here. I have the loop right here. I have the entire loop. And then I can start doing figure eights and other combinations. But those are the 4 basic ones I can pick. It doesn't matter. Matter of fact, I went clockwise on all of these. You don't even have to go clockwise. Whatever you do, I recommend you write it down and you stick with it. Don't try to mix and match techniques, because eventually I will talk about other ways of solving these. I'm going to take this one, which I will label loop A, and I'm going to go clockwise because that's just the way I work through it. And then I'm going to take B. It is arbitrary which ones I took. It's arbitrary which way I drew my circles. But once I establish it, I've now established my convention. As I go around the loop, I know whatever I gain, whatever I gain in potential, I'm going to lose in potential until I get back to my start, which one point I'll be at 0. I'm starting, personally, I like to start just before I cross the battery, because I like the first number to be positive, and again, chocolate scars. So I'm going to go across my battery here. When I go from the negative to the positive, there's the numbers over there. What is my potential difference?
12 volts.
All right. Well, I cruise along, I'm now going across this first resistor. Going across this first resistor, I know I'm going to lose potential. When you go with the current, so current, think of current flowing downhill, I'm going to lose potential energy if I go downhill. So as I go across this resistor, I'm going to lose potential because I'm going in the direction of the current, minus. And then I employ Ohm's law. 1, so it's those who have forgotten Ohm's law. The potential difference is current times resistance. That would get you the magnitude. So I'm cruising along and I go across this resistor right here, so my potential difference is going to be 1 times my current. Resistance times the current. So that is 1, and you don't have to write that. I is D. Now I'm cruising along, I2, there's no resistors there, so there's no loss. I now go across this one. So it's 4, because that's a resistance, times I4.
So, I don't know if this is, if these numbers are realistic, but if you have a 1 ohm resistor, it just doesn't do anything.
I mean, it does something. 1 ohm is small, but
Okay.
yeah, the resistors that we have, we got a whole bunch of 27 ohm resistors, but then we've got some of the mega ohms. I think we might have one under 1 ohm. But typical resistors are going to be in the single digits to 8 digits. So I'm doing my loop here, I'm going around, so I pass this resistor, I pass that resistor, and then there are no more resistors, I get back to where I started, so equals 0.
I see where the systems start coming in.
And now we need one more equation. I said I was going to do the entire loop. Again, pick one of them. I start here, I start at my battery, so I got 12. Actually, someone will take a shot at it?
-1 I sub B.
minus the 27/7. Minus 3.5.
Whoa, whoa, whoa.
Wait, mine's a 27/7, I sub, 1.
Yeah, there we go. All right.
I said, yeah, and then
Minus
minus
I sub.
3.5, I said 5.
3.5.
Yeah. And then 6. Minus I sub P at the bottom, or
Plus I sub P?
And only if it's going across a resistor are you gonna lose.
equals 0.
All right, so one thing I want to point out is that we're writing equations. Equations have an equal or an inequality sign. If you leave off the equals 0, that is not an equation, that's an expression. Now, some people do it as a shorthand and they incorporate the equals 0 later on. Some people don't put the equals 0 in there and just get completely confused. So I recommend putting in the equals 0. So we now have 5 equations, 5 unknowns. It is mathematically solvable. Anyone know how to do this on your calculator? Then let's do it the other way. So we need to reduce it down into, if we can get the 3 equations, 3 unknowns, we can start talking about Cramer's rule. Any of you familiar with Cramer's rule? Any of you dealt with determinants? Matrices.
Yep.
All right, got some matrix people here.
I mean, I know how to put it in the calculator.
Oh, if you can put a matrix into the calculator, then you probably are really close to being able to do system of equations. There is a document that is posted under, I think it's under additional information or extra help or something like that. It's a document created by Mike Jones years ago.